Flack math! Give me some math and I'll give you some flack. Flack math!
All right, so we are going to finally talk about the second step to solving or to factoring. So we're going to talk about factoring the difference of two squares. Factor a difference. What's a difference mean again? Yep, so when you subtract, so subtracting two squares. Now, what do I mean by squares? Like actual geometric squares? What do I mean by squares? Yeah, something that's square rootable. At some point, I started calling it scrutable. So these numbers are scrutable. Okay. Also, like obviously, x squared is scrutable. Right? What's the square root of x squared? X. That's right. Like, is this a trick question? No, it's not. Okay, so let me start with probably the easiest example. If I said something like this, x squared minus 9. Okay, this is not a trinomial. This is a binomial, and the only way you can factor a binomial is if it's a difference of two squares or there's a greatest common factor. Like if this was x cubed minus 9x, you could at least take an x out, right? But it's not. Well, what is it missing? It's missing that middle term, that x term, right? So how many x's are there? There's 0. So you could think of it like this: x squared plus 0x minus 9, right? And then we can ask our magic question. What's our magic question in this problem? What two numbers multiply to get -9, but then when you add them together, they get 0. Well, what is it? What two numbers multiply to get -9, and then when you add them together, you get 0? 3 and -3. Okay. Now, this is cool. So when you factor this out, look what happens. You get x squared. You get -3x. You get positive 3x. And you get -9 in this step. So 2 of you, I've graded 3 of your tests, and 2 of you so far forgot to combine the two like terms. What's -3 and positive 3x combined to? 0x. Well, that works. So you don't really need any of that. So it's just this. Now, if you wanted to do it this way, you could pop a 0x in there and then ask the magic question. But the shortcut to factoring the difference of two squares is real easy. The first, you still get x and x because it really is just the square root of the first term. And then one of them's added, one of them's subtracted, and then it's the square root of the second term. Okay? So I wrote this down over here, but basically it's the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. Okay? So all we did was square root that first term and put it in that first position, right? We square rooted the second term and put that in the second position, right? And then one of them's added, one of them subtracted, and you're done. So factoring a difference of two squares is incredibly easy. I'll prove it. Watch this. Here's my first example. Well, example 0, I guess. 9m squared minus 49. Well, start with your parentheses. Now, what did I say? What was the shortcut? What do you do? Times. What is it? So how do I factor this? So did none of you write down the shortcut? What's the shortcut to factoring a difference of two squares? Times what is it? Okay, write this down, poopy heads. The square root of the first plus the square root of the second times the square root of the first minus the square root of the second. You can't get much easier than that. You know what makes it hard? Trying to remember it at 8:07 in the morning. So write it down, write it down, write it down. Okay, and here it is up here too. Look for a difference of two squares. That's part of factoring. So the square root of you see it? Okay. All right, let's try another one. You guys ready? So they might try to throw you off here because really it's a difference because you're subtracting, and it's two squares because you can. This only works if you can take the square root of both the first and the second term. Okay, if you can't, it doesn't work. Here's another example. Example 1, we'll call it. -4 plus x squared. Well, this doesn't look like a difference, does it? Does that look like a difference? It doesn't have a subtraction sign, but you can write it as a difference. How do you write it as a difference? What's another way to say -4 plus x squared?
X squared minus 4.
Yeah, x squared minus 4. Now it's a difference of two squares. Factor it. Go, go. Go, 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 go. Okay, what'd you get? Rihanna, you got it?
I think I have one.
All right, what do you got?
So like I have x plus 2 times x minus 2.
That's it. That's it. Don't overcomplicate it, guys. Once you have a difference of two squares, all you do is scrape the first and scrape the second, add them and subtract them, and you're done. Okay? When you multiply this out, if you're still not getting this factoring thing, if you're not getting this, you're not going to get this. Okay? Well, maybe you get this when you don't get this, because the shortcut here is real easy. You just square root both of them. Okay? When you multiply this out, you get 9m squared plus -21m. Right? When you're foiling it out, then you get plus 21m, which cancels, and then you get minus 49. So you're left with what you started with. Okay? So if you're still not getting it, make sure you foil it out, test it, check your work. Okay? All right, we're going to try 3 more problems. Okay, you guys need to do this. Practice this. Example 2. (49m squared minus a squared). There's example 2. Here's example 3. -36a squared plus 25y squared. Here's example 4. -36 x to the 6th y to the 4th plus 49a squared. They try to make it difficult, but if you're understanding this, none of these are difficult. Okay, raise your hand if you want to share your answer to example 2. I need a volunteer for example 2. Okay, Elkin. Example 3. I need a volunteer for example 3. Okay. Anybody got 3? Will anybody have it by the time we get to number 3? Okay, Brianna, do you want to share your example 3 answer when we get there?
I can.
Okay, and then example 4. Example 4 looks a little ominous. But here's the thing with factoring the difference of 2 squares. It's really hard to make these hard. Okay? Because if you understand the basic concept and the shortcut, then you shouldn't have any issues. All right, Elkin, what'd you get for A?
I got 7m plus a times 7m minus a.
Perfect. Square root that, throw it there. Square root that, throw it there, and you're done. Good. Rihanna, do you have yours for example 3?
Is that a cube?
What's that?
Is that a cube?
This?
Yeah.
Oh, it's an A, but
Oh, that was cute.
I don't think it matters. I mean,
Okay, well I got 6a plus 5y
okay.
times 6a minus 5y.
Okay, so you're very close. Now, what you didn't do is write this as a difference of 2 squares. So the only thing you messed up was that 6a minus 5y. It should be 5y minus 6a. Here's why. Because if you write it as a difference of 2 squares, now you do your thing. So it's 5a or 5y, 5y, and then 6a and 6a, add, subtract, you're done. Okay? So that's the only thing you did wrong. But you understand the concept. So first it has to be written as a difference of 2 squares. All right, who's got the third one, or the last one? Example 4. All right. What do you got, Audrey?
7a plus 6x to the third y to the second. 7a minus 6x to the third y to the second.
Perfect. All right. So first she wrote it as a difference of 2 squares. So right now it's a negative number plus a positive number, which means I can write it as that positive number minus the negative number, right? So 49 a squared minus 36 x to the 6 y to the 4. So square root of 49a squared is just 7a, right? Everybody got that? Okay, now square root of 36 is 6. Square root of x to the 6. What's the square root of x to the 6? Just x to the third, right? Because when you square root an exponential expression, you just divide the exponent in 2, which is kind of weird because we were taught, no, when you take the square root, you don't divide by 2. Well, when exponentially you do, okay? So what's the square root of x to the 14th? X to the 7th, just cut it in half. So this is x to the third, and then y squared, x to the third, y squared. One of them's added, one of them subtracted, and you're done. See how it's difficult to make these difficult? Now that we've kind of gone through the most difficult ones that we could possibly do, then now you can do anything, okay? So that's as hard as it's gonna get, that last one. You might have to switch the order. And you might have to divide an exponent by 2, as well as take the square root of the bigger number, right? But that's it. That's as hard as it's going to get. Okay? Can you handle it? All right. The last part of this lesson, we're going to talk again about probability. I like probability when I understand it. But so one time when I was in college, my friend from high school moved out from Iowa because I went to high school in Iowa, but we were in California at the time. So he drove out there. He was from Iowa, so he was like, I've always wanted to go to Vegas. So we got in the car and we drove to Vegas, and he put like some quarters in a slot machine or whatever, and he won like the second or third quarter. He won like $100 in a slot machine, and then he was like, I could just live here. Like, this is awesome. Like, why do I ever have to work again? I could just live here and put a quarter in every few hours and get $100. So obviously that is called luck. And I was thinking about it, and I was like, what if there's like people like in a security room and they have cameras on everybody? Ooh, and they look at that guy. He's never been here before. Let's get him $100 as an investment, because then he won't ever go away. He'll keep putting money in our machines because he thinks he's going to get $100 every 3 or 4 quarters, right? So I was convinced that there was like guys in rooms watching video monitors looking for idiots, basically. He's not an idiot. Doug, you're not an idiot. I believed it too. I actually won too. So he like I think he won like not $100. I won $100 because he won like $250 or $500 like the 4th or 5th quarter, and so he gave me a bunch of quarters, and he said, "Hey, go play so we can make more money." So I did. I won $100, but yeah. So he kept going back and just lost a lot of money. So anyway, probability, it's important to know. If Doug knew probability, he probably wouldn't spend that much time in Vegas. Okay? Now, I'm not saying don't play cards, don't gamble or whatever. But if you're trying to do it to make money, it's not a good living. It's not a good idea. It's fun to play every now and then, but you're going to lose most of the time. And as long as you're okay with that, then don't worry about it. I mean, don't bank on it, literally. Okay. All right. So let's talk about probability. Let's say, let's do this one first, since we're talking about cards and what not to do. What's the probability of drawing 4 aces from a deck? How do you figure that out? How do you figure out the probability of drawing 4 aces out of a deck? Well, what's the probability of drawing 1 ace out of a deck? So how many aces are in a deck? 4. So it'd be 4 out of 52, right? Okay, so probability of doing an ace, 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 ace is, remember, the probability of an ace times the probability of an ace times the probability of an ace times the probability of an ace, right? So remember, when you want it to happen in a certain order, you just multiply the probabilities. Question?
Could we just write it as 4/54 to the 4th power?
Good question. Now, you would do that if, after you drew your first ace, you put it back in the deck. But is that how you play cards? No. You get it depends on the game, but in poker, you get 5 cards, sometimes you get 7 cards, whatever. But the probability of getting 4 aces is this. The first one is 4 out of 52. What's the second one? How many aces are in the deck now? Because you already have 1, right? How many aces are in the deck? 3. And how many cards total? Right? What's the next one? 2 out of 50. And then 1 out of 49. Did you see what I did? All right. Well, let's see if we can reduce this. This is just 1/13. This is just 1/17. This is just 1/25. And that's 149. Elkin, on your calculator, multiply 13 times 17 times 25 times 49. And what do you get?
A big number.
What is it?
270,725.
Okay, so your chances are pretty good. one and a quarter millionth of getting 4 aces. So, you should just go for it. Or not. Okay? So, like that, when you're playing cards, it's good to Rain Man it a little bit and count and calculate the odds. Like maybe you're down at the bottom of a deck. You're like, I really think I'm going to get another ace. I mean, I already have 3 aces. I think I'm going to get that last ace. Don't bank on it. Don't play cards that way. I'm not telling you how to play poker or whatever, but it's good to know the odds. You save a lot of money, don't you? You save a lot of money when you know probability. All right, let's go back. These are the kind of problems you might get. Let's say that an urn, apparently urns hold ashes and marbles. This is what they do most of the time. And coins and stuff. Skyrim, that's right. So urn has 3 black marbles. And 5 white marbles. Okay, what's the probability of drawing 2 black marbles in a row? Okay, well now I have to ask this question, a clarifying question. Well, after you draw the first one, are you going to put it back in the urn or are you going to hold on to it? So we call this with replacement or without replacement. Okay, so what's the probability of drawing 2 black marbles in a row? Okay, so what's the probability of drawing the first black marble? 3 out of 8. This will never change. Whether you replace it or you don't, the first probability is the same. It's the same odds, right? The same probability. Okay, so let's say we keep it. What's the probability of drawing it again? Well, we don't keep it, we put it back in. So this is called probability with replacement. You guys know the little abbreviation for with? W and then the slash. Okay, well, what about without replacement? And the W/O is without replacement. So the first one's the same. What's the second one? Eliana? 2 out of 7. Okay, so the chances are different. So this would be 9/64. This one would be, let's see, 3/28. Okay, so this is a little bit more than an 1/8 of a probability. This is a little bit, I don't know, a little bit less than a 1/7 or a little bit more than a 1/9. A little bit less than a 1/9. A little bit less than a 1/9. Okay, a little bit more than an 1/8, a little bit less than a 1/9. Okay, so it makes a difference. Okay, so this is just one example. Let's try another one. Okay, and then we'll end the lesson with this. So you guys try this. Here's example 6. We have an urn. There's 4 red marbles. There's 7 blue marbles. And there's 2 drawn. There's 4 red, 7 blue. I want to know the probability of a red, then a blue. Okay? And I want to know with replacement and without replacement. So calculate both types, and you'll get this in your homework and on the next test. you'll have to calculate the probability with and without replacement. By the way, we're not going to have another test until after spring break. So that'll be nice. All right. Elkin's shaking his head. I'm going to color coordinate this just because I can. All right. So somebody want to volunteer to give me how they did the probability with replacement? Who would like to volunteer? Elkin? All right. What'd you get for the probability of red?
So I did 4/11 times 7/11. I got 28/121.
Okay. Put it back in. It never affected how many blue marbles anyway, but it does affect, it does affect how many total they're in. So if you put it back in now, there's still a total of 11 because that red got returned, right? And so what is that? 28 1/21st? Okay. All right. Who wants to tell me without replacement? Do you have it, Zan?
I only got to the top.
Okay. Well, do you want to walk me through how you do it without replacement? But do you not understand it, or you just? Okay. All right. Well, I'm going to walk it through it with you. Okay. So what about the first one? So remember, it's still drawing a red first. So what's the probability of drawing a red out of there?
4.
Yep. So that one doesn't change. The first one's always the same. Okay. Now you've got one less red, and you got one less total. Well, how many blues do you still have?
7.
You still have 7, right? Because you drew a red one, not a blue one. Now, how many total do you have? 10. So now that changes things just a little bit, not much, but it made our denominator a little smaller, which means our probability is a little greater. Okay, so this, instead of 28/121st, it's 28/1/10. But this cross cancels, and you get 14/55. Don't forget to reduce. Oops, that's not the answer. That was another problem. Okay, don't forget to reduce your probabilities. They are fractions. Don't judge them just because they're probabilities. They're still fractions, so reduce them if they can be reduced. Okay? Probability, it doesn't have to be fractions. It could be like you have a 50% chance of flipping a heads on a coin, right? So it's still 1/2, 50 out of 100 or whatever. It can be a decimal. Your probability could be 0.5, right? All right, so that's 73. Let's move on to 74. 74 is a major review. It's just scientific notation, but we are going to start multiplying and dividing in scientific notation, which really isn't too complicated. It's just 2 parts. You have to multiply the big numbers and multiply the powers of 10. So it's not bad. Same thing with division. You got to divide the big numbers and then divide the powers of 10. Well, you already know how to multiply exponential expressions, right? What's 10 to the third times 10 to the fifth? 10 to the third times 10 to the fifth is 10 to the eighth, right? You just add the exponents, right? You're multiplying 10 3 times, and then you're multiplying it another 5 times. So you're multiplying it a total of 8 times. Okay, so we're going to talk about psi naught. Okay, and as you know, the reason we do this because many times in science you've got either really big numbers or really small numbers. Okay, so does anyone know how to say that number?
Comes after trillion.
What comes after trillion? Do you guys know?
Gazillion.
Well, what comes after try?
Trinomial.
Quadrillion. And then what comes after quad? Starts with the Q as well.
I want to say quintillion, but I don't think that's it.
Quintillion. So you've got 26 quintillion, 890 quadrillion. That's how you say that. So no one wants to say that, right? So we use scientific notation. Remember the steps to psi naught. Do I have them up here? I don't. I should write them up here. Steps to psi naught. The first step. This is what I have to tell most students because it's hard to get their heads around this. So here's the steps to scientific notation. First step, put decimal after the first, and I have to say non-zero digit. I have to do that because when I start to do the real small decimal numbers, there's already zeros in front of the first non-zero digits. First non-zero digit. Okay, that's the easy step. So the first step is just 2.689, and then I don't need all those zeros, right? But does this number equal this number? How do I make this number equal that number? Elkin?
Wouldn't you count all the spaces on the right side of the decimal,
Yep.
including the numbers, or
Yep,
just the zeros?
including the zeros. So
Okay.
1, 2, 3, 4, and then plus 15. So what's this? What do I multiply by?
10 to the 19th.
10 to the 19th. That's easy. Okay. So you just have to multiply by a power of 10 that will get that decimal back to where it started. Okay. So step 2, multiply by a power of 10 that will return the decimal. Back to its origin, where it started. Okay, that's it. So it is kind of backwards thinking. We're not moving a decimal. Okay, we're not moving a decimal at all. We're just saying if the decimal was here, then we'd have to multiply by 10 to the 19th to equal that. Okay, so this value doesn't change at all. If you were to move the decimal there and then don't multiply by a power of 10, that's wrong. You're not changing the value. You're just writing the question to a math problem. So this is the answer to the math problem, and you have to write the question. The rule is this number has to be in between 1 and 10. Okay? If it's not, you put the decimal in the wrong place. So that's why I say put it after the first non-zero digit, because that guarantees that that first number is in between 1 and 10. Now, when I multiply this number times something, I'd much rather multiply a number that's in between 1 and 10 times another number that's in between 1 and 10. So that's why we do this, because I can multiply powers of 10 all day long. You just add the exponents, whatever. And your calculator will thank you, because what happens if you put that in your calculator? It's going to cry. It's not going to cry. But you know what that E stands for? You know, it's not, doesn't stand for error, even though you think it does. Oh, my calculator says error. It doesn't. If you write this in your calculator, it's going to say 2.689 E19 is what it's going to say. That's not an error message. That's scientific notation. So that E says times 10 to the 19. Okay? All right. So that's all review. This is stuff we started doing in Math 7 and then into pre-algebra. So now what do we do with it? Well, we can use it. All right. So let's just do one more example here. So here's a number that's way like this. How do you write that in scientific notation? Same steps. What's the first step?
Put the decimal after the first non-zero digit.
Yep. What's the first non-zero digit? 4. So 4.16. First step done. Okay. Now, how do I make this equal that?
Would you do 10 times the negative fifth?
Yes. So this time I'm going to go left 5. So this tells you move the decimal, left 5. Move the decimal, right 19. Okay? So, and you can even multiply these two numbers together. Because if you do that, you multiply, that's going to be like 8 point something. And then this is going to be 10 to the 14th because you just add the exponents. That's it. Okay? I think there's a scary movie happening across the hall. Okay, so that's all review, but now what do? Well, I guess we just stay there for a week. Okay? Can you guys do some homework? That is this stuff. I think you can handle that. But I'll put 4 examples on the board, and you can try these. So we're not multiplying quite yet. So write that in scientific notation. Write this in scientific notation. Okay? And then write this in scientific notation. Actually, did I say 3 examples? I'm going to do 4 and a little bit more. So here's example 3. Okay, let's do the first 2 together. How do you do this? What is this? Somebody got it? Yep, that's it. No problem, right? What about this? Uh-oh, what's the issue here?
It's not.
Yeah, there's already a power of 10. Okay?
Do it at another power 10.
Yeah, with another power of 10. So I would just start there. Well, we already know what that is. What is it? That's just 3.16 times 10 to the negative 4th. But that's all times 10 to the negative 7th. Does that scare you? What? Yeah, you just add the exponents. That's it.
10 to the negative 11.
That's not bad, right? Can you guys handle that? Okay.
Same thing from 3.
Yeah, so what do you, can you do that in your head?
It's 0.16, 10 to the 3rd.
Yep, 10 to the 3rd. So this is 3.16 times 10 to the negative fourth, all times 10 to the seventh. So when you start doing negative numbers, negative exponents and stuff, sometimes it's hard to do that in your head. So I would recommend writing it out. But if you can handle it in your head, do it. So this is 3.16 times 10 to the positive 3. When you add the exponents together, you get positive 3. Good? All right. The last few. I'll just try one more and see if I can stump you. Okay, this is example 4B. So try that one. So 47,800.
Okay.
Wait, that's a dot.
It's a comma.
So why is it the dot? Are you trying to confuse us?
No, like a comma has a dot in it. Did you know that? It's like a period with a tail.
I did not know that.
Yeah.
That's. Okay. Done.
Everybody done? What'd you get, Elkin?
I got 4.78 times 10 to the negative third.
All right, let's see if he's right. So how do you write this?
4.78.
Times 10 to the,
Negative third.
well, that's the final answer. But this is to the fourth. And that's all times 10 to the negative seventh. And you can do this in your head. It's not impossible. But it gets, like I heard somebody say, oh, I went the wrong way. It's hard to do that in your head. What is this? Is that is that a ring? What is this? Yeah. Oh. Okay, so just add the exponents and you're done. Okay, that's all I got.
Flack math. Give me some math and I'll give you some flack. Flack math.